class. So we have a footing. So a square footing that has a load of, let's say, 2,400 kilonewton. And we're going to determine the width of our square footing. So we're going to determine the width of our square footing. So we're going to use what? We're going to use terzagis para mas madali. Terzagi siya, and we're going to have a factor of safety of 3. Okay, so etong ating footing ay nasa depth na 2 meters. And ang ating angle of friction is 32. Cohesion is 50 kPa. And ang ating gamma is 17.25 kilonewton per meter cube. At ang water table natin ay 1 meter below the footing. Below the depth of below the bottom of the footing. So we have here 1 meter, and dito ang ating groundwater table. And ang gamma sat dito is what? 19.5 kilonewton per meter cube. Okay, so wait lang. Ibahin naman natin yung kulay ng ating groundwater table para naman, diba? Okay, para naman makita ang groundwater table nga. Okay, so nating blue. Okay, so andito ang ating groundwater table. So 1 meter. So groundwater table yung kulay blue dyan, ha. So gamma sat is 19.5 kilonewton per meter cube. Anong dinedetermine natin, class? What is required? What is required is the depth of the footing, diba? So if the groundwater table is 1 meter below the depth of the footing, so paano natin yan kukunin, class? So we're going to use terzagis. So ano yung formula ni terzagi, class? Sa QU, QU is equal to CNC plus QNQ plus gamma BN gamma. Total, this is a square footing. We're going to use 0.4 here. And since this is not the original equation, we're going to use 1.3 there. Okay, so saan natin gagamitin yung factor of safety of 3? So we are going to have it as QU over factor of safety. It is equal to the allowable bearing capacity, which is equal to allowable bearing capacity P over area, at yung P natin ay 2,400 over area of a square, that is PB squared, diba? So ang gagawin natin ay kunin muna natin ang ating QU. QU 1.3 C. Ano ang C natin, class? Our C is 50, tama? NC. Okay, so hanapin pala muna natin ang ating bearing capacity factors. So when phi is equal to 32 degrees, ang ating NC ay 44.04, NQ is 28.52, and N gamma is 26.87. Okay, so going to use QU 1.3. C is 50 times 44.04. Ano naman ang ating Q? Okay, so question ng Q. Ano ang Q natin, class? Q is the effective stress at the bottom of the foundation. So ano kaya yung effective stress at the bottom of the foundation? So since dry naman siya, that is what? Our Q there is equal to 17.25 by 2. That is what? 34? Is that 34 or 39? 17.25 or 34. So it is 34.5 kPa. So lalagyan natin 34.5 times 28.52 plus gamma. Ano yung gagamitin nating gamma? So in this case, class, it is best to assume that what we're going to, na kung anong case yan, probably that is what? Probably that is case 2 kasi alangan namang less than 1 meter yung ating width of the footing, diba? So, assuming, class, it is best to assume that that is case 2. So, for case 2, the gamma is equal to, ano yung gamma natin sa case 2, class? Gamma buoyant plus it is gamma buoyant plus D. Ano yung D? Difference nung depth of the water table sa depth of the footing times gamma minus gamma buoyant over B. At ang gamma buoyant natin ay gamma sat minus gamma of water. Ano yung gamma sat? That is 19.5 minus 9.81 plus, ano yung difference ng depth of the water? Ano yung D natin? Our D is what? It is obviously 1 meter. Diba? Ito yung D natin. This is the distance D. Okay, so that is 1 meter times gamma. Ano yung gamma natin? That is gamma dry 17.25 minus gamma buoyant. Ano yung gamma buoyant natin? 19.5 minus 9.81 all over B. That is unknown. So, ang gamma natin ay 19.5 minus 9.81. That is 9.69 plus 17.25 minus 9.69 is 7.6 over B. So, ito yung isa-substitute natin dito. So, hindi na siya kasya. Ito sa gamma B and gamma times 0.4. Okay, so hindi na siya kasya. Lipat natin QU 1.3. Ano yung C? 50 NC is, I forgot the NC. What's the NC? 50 44.04 plus, what's RQ? 34.5 times 28.52. At yung gamma natin ay 9.69. 0.4 pa pala, no? We have to, okay, have to 0.4 gamma 9.69 0.49 gamma 9.69 plus 7.6 over B gamma B N gamma. Ano yung N gamma? 26.87. Okay, so simplify na natin itong 1.3 by 50 by 44.04. That is 2862.6 plus 34.5 times 28.52, 983.94 plus, i-simplify natin to. 0.4 times 9.69 times 26.87 times B. That is 104.15 B plus 0.4 times 7.6 times 26.87 over B times B. Cancel ang B, so it would become plus 81.68. So, pagsamahin natin lahat ng magkakaparehas. So, 2862.6 plus 983.94 plus 81.68, it is 3928.22. 3928.22 plus 104.15 B. So, that is our QU. Para saan ang QU class? Kasi nga, ang gagawin natin, kukunin natin ang B, i-equate natin yung Q allowable is equal to QU over factor of safety. That's, ang QU is, at ang Q allowable natin is equal to P over area, that is B squared. At ang P natin ay 2,400 over B squared. So, ang gagawin natin, i-equate natin 2,400 over B squared is equal to 3928.22 plus 104.15 B all over 3. So, ang mangyayari, gagawin natin 3 times 2,400, 7,200 is equal to 3928.22 B squared plus 104.15 B cube. Okay, so isa-solve natin ang ating B. So, how are we going to use that? Solve that one? We are going to use our calculator. Okay, so sa calculator, input natin negative 104 point, ay hindi, negative daw. It is positive pala. 104.15 plus 3928.22 0 minus 7,200. At ang B natin ay okay, dalawang imaginary at isang 1.33 meters. So, ang answer natin is 1.33 meters. So, if you are going to the problem class, we are given a foundation with the following properties. Ang properties, given yung gamma dry, given yung gamma sat, given yung location ng water table. Asan yung water table? Asan yung water table? Andito yung water table natin. So, given yan. Gamma sat, given yung ating load. That is 2,400 kilonewton. Ano pang given? We have what? Our C and our angle of friction. And then, we are going to get B. Tama? And then, ang B na nakuha natin ay 1.33 meters using Terzagi's bearing capacity factors. Okay? What if class? Ang next question naman natin, what if ang nangyari sa situation na yan ay dyan sa problem natin ay itong ating footing that carries 2,400 kilonewton 2,400 kilonewton na load. Yung water table natin, from 1 meter, the depth of the footing, umangat siya dito sa ating ground. Yung groundwater table natin ay andito sa ating ground, meaning ito ay saturated, diba? So, ano ang gagawin natin, class, if lahat ito ay saturated? Kasi nga, yung groundwater table natin is umangat dito sa ating ground surface. So, yan yung isang problem. So, anong case yan, class? Ang gagawin nating case dyan is case 1. Anong meron ulit? Parehas, class. QU 1.3 CNC plus QNQ plus gamma BN gamma times 0.4 kasi square. Okay, so let's have 1.3, 50, 44.04, but ang Q natin iba na. Bakit? Ang Q natin ay yung Q dito sa bottom of the footing, our Q there is Q is equal to saturated. So, since umangat na yung tubig natin, so lahat na yan is saturated. So, our Q is equal to 19.05 times 2 minus 9.81 times 2. Kasi, ito ay 2 meters. Diba? So, solve natin. 19.05 minus 9.81 times 2. That is 18.48 kPa. So, plus 18.48. Ano yung NQ natin? 28.52. Plus 0.4 gamma. So, ano yung gagamitin pala nating gamma dito? Ang gagamitin nating gamma, yung effective gamma dito, that is what? Effective gamma there is the gamma buoyant. 9.05 minus 9.81. Ano yun? That is 9.24 kilonewton per meter cube. So, we're going to substitute 9.24 kilonewton per meter cube. B times N gamma, that is 26.87. So, ang QU is equal to 1.350 times 44.04 plus 18.48 times 28.52 plus 0.4 times 9.24 times 26. Ay, di pala pwedeng i-plus kasi may B pala siya dun. So, i-plus pa lang pala natin ay yung first two terms, that is 389.65 plus, separate natin, 0.4 times 9.24 times 26.87. That is what? That is 99.31 B. Okay? So, equate natin ulit na ano yun, Q allowable is equal to QU Fs, where Q allowable is equal to P over area, B squared. So, ang QU natin is, anong QU natin? 3389.65 plus 99.31B over factor of safety of 3 times 2,400 over B squared. Okay, so it would become 3389.65 B squared plus 99.31 B cube equal to 7,200. Okay, so equate ulit natin siya sa ating calculator. We have 99.31 as B, 3389.65 at B squared, 0 na X, and negative 7,200. So, dalawang imaginary and isang 1.43 meters. So, anong napansin, class? So, kapag kanina, yung unang scenario natin, kapag yung ating water table, dalawang scenario natin, di ba? So, we have this one, and yung solve natin kanina. Okay, so, kanina, ang water table is andito. Ngayon, yung water table naman andyan sa taas. So, ito, 1 meter mula dyan. At ang B natin dito is 1.33 meters. At ang B naman natin dito is 1.43 meters. So, yun yung groundwater effects, class. Kapag kasi, ang ating footing ay exposed sa groundwater, class, malaki kasi yung tendency niya ng uplift, 'di ba? Kaya mas malaki yung kailangan niya na area, mas malaki yung kailangan niya na part ng pagdidistributan niya ng load. Kaya yung B natin dito is 1.33 and yung B natin naman pag umangat yung water table natin is 1.43. So, what if, class, kung yung groundwater table natin ay nasa pinakamalayo, walang effect, meaning mas maliit pa yung required na B. So, you have to note that as the water table elevation increase, the required width will also increase. So, as the water table increases, the required width will also increase. So, yun, class. So, lalo na kapag walang effect yung groundwater table, ibig sabihin, mas maliit lang yung B na kailangan natin. Okay?